Good day and welcome to the Math Salon. I'm Dr. Animendem. Today we are going to look at an advanced level question, paper 2 on trigonometry. This question has so many aspects in them, so I think it's important we pay a bit of attention because the skills that you would get from this can really help both in the paper 1 and paper 2 for different situations. Okay, so we start. So there are quite a few of them. There are 4 parts for this question. So you have the first one says, express 2 sine theta cos 6 theta in the form sine p minus sine q. If you look at the factor formula, then you would see that based on that, we can show that sine p minus sine q is actually equal to 2 sine p minus q divided by 2 cos of p plus q divided by 2. You can actually prove this, but usually you receive a formula book during a mathematics exam, and from the booklet you can actually pick this out. So it's not necessary to keep, except you'll be required to prove. For this particular video, we will not do that. It takes some time, but I already illustrated in some previous videos how those relationship and identities are. It's not a complicated one. In fact, it's really simple. But let's just go ahead. Let's assume that you know the sine p minus sine q, or at least you can get from the booklet, is equal to 2 sine the difference, half of the difference between those angles, and that if it was sine p plus sine q here, then this will become plus and this will be minus, just that you take note. So the first question expects that we express this. So we have to express 2 sine theta cos 6 theta in a form as sine p minus sine q, something like that. So basically what we are saying is we are looking at this as the right hand side of this formula, and we want to take it and make something for the left hand side. So if I compare these two, then I will see 2 is exactly with 2. Sine is sine, so the relationship I find there is this and this one. That means p minus q divided by 2 is equal to theta from this part and this one, and this one. So if I arrange this properly, then that is p minus q is equal to 2 theta. And we'll call this equation 1. The next is this one. P plus q divided by 2 is equal to 6 theta. So if I multiply both sides, I get p plus q is equal to 12 theta. Let's say equation 2. So what we're left is just to solve these two equations for p and q, and we'll be done. So if I look at this equation 1 and equation 2, I see that this is minus, this is plus. So if I sum the two of them, the q's will disappear and the p's will stay. So this will become, so equation 1 plus 2 will be p plus p is 2p, minus q plus q goes away, 2 theta plus 12 theta is 14 theta. That means p is equal to 14 theta divided by 2, and that is 7 theta. Then next, now, once we've obtained p, we can choose any of the equations to get q from. Let's say we take one. So we substitute for p in 1. If we do that, then I get the 7 theta minus q is equal to 2 theta. That's what is there. I can take q to this side and this to this side. Then that is 7 theta minus 2 theta is equal to q. And 7 theta minus 2 theta is 5 theta. So q is equal to 5 theta. So basically then it means that 2 sine theta cos 6 theta can be expressed as sine p, our p here is 7 theta, minus sine q, 5 theta. That is it for the A part. I will erase the board so I get space for the B. So it's good to keep in mind that we already have seen that 2 sine theta cos 6 theta actually can be expressed as sine 7 theta minus sine 5 theta. So the B says, hence, prove that 2 sine theta into brackets cos 6 theta plus cos 4 theta plus cos 2 theta is equal to sine 7 theta minus sine theta. So I will take my right hand side there. It is written as 2 sine of theta into brackets cos 6 theta plus 4 theta, cos 4 theta plus cos 2 theta. We expect to show that this is sine 7 theta minus sine theta. So we'll start from the left hand side. If I open this up, I get 2 sine theta cos 6 theta. 2 sine theta times this become plus 2 sine theta cos 4 theta plus 2 sine theta cos 2 theta. So we'll leave the right hand side for now and see if we can work with the left hand side and do some work in the saloon to come out with the right hand side. Now we need some recognition. We just already deduced. You see, it was a hence, means you should use some information from A to be able to do that. We already saw that sine 2 sine theta cos 6 theta is equal to 7. Sine 7 theta minus sine 5 theta. So we can, this is already from here. So that's simple. This is here, sine 7 theta minus sine 5 theta. We can use the same ideas when we come to something like this. So just see what happens. 7 theta is 6 theta plus theta. And then 5 theta is the one 6 theta minus theta. So it's something you can just do at once. Excuse me. So here it is simply going to be theta plus that. So that's sine 5 theta. That's 4 theta plus theta. And minus, now that part is there. Let's keep it like this. Then the rule says minus the one that is the smallest one, so we get the smaller part. So 4 theta minus theta, that's 3 theta. Plus into brackets, we get this last piece here. This is sine, this plus that, that's 3 theta, minus the difference, sine theta. So we are left to open this up and fix it and wash off the dust or the shampoo that we have put on the head. So this becomes 7 theta minus sine 5 theta plus sine 5 theta minus sine 3 theta plus sine 3 theta minus sine theta. If you watch this very well, this is a minus, this is a plus, so they can go off. This is a minus, this is a plus, so they can go off. And left only with 2 terms, and that is sine 7 theta minus sine theta, which is what we expected to show. So that's for the B part. Let's move on to the C part. So we say deduce. That means you still have to use some information that you've already been able to show or verified in the next step. So we ask now to deduce that the cosine of 12 theta over 7 plus the cosine of 8 theta over 7 plus the cosine of 4 theta over 7 is equal to minus half. Once again, we will concentrate on our left hand side and be able to show that it's equal to minus half. But we have to deduce. From the B part, we already showed that 2 sine theta into brackets cosine of 6 theta plus cosine of 4 theta plus cosine of 2 theta is equal to the sine of 7 theta minus sine theta. If I try to compare this and this one, I see that the only common part is this here that looks similar. So this thing should not be here. So one way I can do that is divide both sides by 2 sine theta, so it comes to this side. So if I divide here all by 2 sine theta and divide here also by 2 sine theta, then this one goes away. Then I can write it now neatly to say that then this is simply the cosine of 6 theta plus the cosine of 4 theta plus the cosine of 2 theta. Yeah, this is okay now. All of them are cost quantities. And because I have to deduce, then I have to make some comparison here. I have all 3 cos. It means that my 6 theta should be equal to this, 4 theta should be equal to that, 2 theta should be equal to that. You just have to choose one of them. The intention is to be able to look for theta so that we can use it on this right hand side and show that it's equal to minus half. So if that is true, we can say that 12 pi, on 7 is equal to 6 theta. So if you divide both sides by 6, your theta will be equal to 12 pi on 7. When you divide by 6, it's like multiplying by 1 over 6. So this cancels off there and goes, and I have 2 pi on 7. 6 here, 1, 6 into 12, 2. That becomes 2 pi divided by that. So my theta is 2 pi on 7. And because we've shown that this expression can be written like this, and we've manipulated to this, I can substitute theta into this. So if that is the case, then if I put theta here, so my new equation, so if you just want that, so that means cosine of 12 pi on 7 plus cosine of 8 pi on 7 plus cosine of 4 pi on 7 should be equal to the sine of 7 times theta that we just saw. So because now I'm working, I've already deduced theta, so I have to replace. I just use this as a path to what I'm supposed to do. So my theta is 2 pi here divided by 7 minus sine of that theta, that is 2 pi on 7 divided by 2, the sine of theta. Theta is 2 pi on 7. If you arrange this properly, the 7 here goes over the 7, and I get sine 2 pi. But sine 2 pi is equal to 0. Sine of 360 is 0. So that is 0 minus the sine here of 2 pi divided by 7 divided by 2. The sine of 2 pi divided by 7. Of course, this 0 is useless, not useful. So the sine 2 pi divided by 7 cancels off, and I get minus 1 above and 2 below, which is what we expected to show them. So we go now to the last one. I wouldn't go to the details too much, so I see. So we are just left to look for the general solution of this equation here. So we said the general solution should be for sine 7 theta minus sine theta divided by this is equal to that. Just take this one, look from here. If you see from here, you will see a relationship. We already saw that 2 sine of theta, the brackets cos of 6 theta plus cos of 4 theta plus cos of 2 theta is equal to sine 7 theta minus sine theta. This information is known, and we've been able to prove that that is true. The only thing is I try to recognize what I have here with that. So what I say is, if I divide this both sides by the whole of this term, then I get that 2 sine theta should be equal to sine 7 theta minus sine theta divided by cos 6 theta plus cos 4 theta plus cos 2 theta. You see? But this is equal to 1. So I can say this is equal to 1 according to this. So what I'm left to solve is, solving this equal to 1 is the same like solving this equal to 1, because they are the same. That means 2 sine theta is equal to 1. And sine theta should be equal to half. So to solve for theta, the general solution for the sine theta will simply be equal to the sine. This is supposed to be the sine inverse of pi on 6, 30 degrees. Sine 30 degrees is half, so I can use it that way. Once I can write sine theta is equal to sine inverse of something that is there, then that's fine. Then I'm okay. I can say that that's true. So in that case, this is my new angle. That is the pi on 6, and it's going to be 2 pi k plus or minus pi on 6. That's the general solution, because sine well, excuse me, just made a small thing there. So there are two. Sine is positive in the first and the second quadrant. So the first solution is equal to 2 pi k plus pi on 6, or in the second quadrant is going to be 2 pi k pi minus pi on 6. So this is the first quadrant, this is that, and the second quadrant. So this is the general solution for our theta. Hope you did understood the whole process, and that you got some skills to be able to handle other ones. Remember, thumbs up, subscribe in order to be alerted when you have new videos, and most importantly, that you share with your friends. It's very important that we all work together to succeed. Bye.